Alrighty, so we're going to look at the processes that create the platform at Muriwai Beach in the Muriwai coastal environment. Our platform is called Fisherman's Rock. So when you're writing your essays, you introduce it as a shore platform, which is the correct geography term for it, and then you give it its name, Fisherman's Rock, specific terminology, and then you carry on writing your essay or whatever referring to Fisherman's Rock. So what are the processes that have caused our Fisherman's Rock? First of all, where's it located? It is located on the northern side of Otakamedo Point. Alright, so when you're referring to it, when you're introducing it, give it as much location detail as you possibly can. Rightio, so the processes, number one, that wind. Alright, so we've got our climate processes. That 2,000 kilometre fetch creating 2,500 to 300,000 kilojoules of energy in our waves. That then transfers that wave, so the wind to waves, the waves to the headland. So there's that transfer of energy happening. The key wave processes that are happening at Fisherman's Rock, just like the other processes on the headland, it's that wave pounding, transfer of energy, hydraulic action, the wind, the air being forced into crevices, weakening the structure. Then we also have attrition and abrasion, so those rocks and sediments working in a filing sort of system to take away more material. So what happens is we have all of these wave processes are happening, and what they eventually do is they actually create this here, which is a notch. So you can actually see the different layering of the sediment. We can see that this is clearly an area that gets high attack by the waves, or it could be an area of weakness in the structure of the geology. Either way, this notch has been created. We also have a weathering element here, all right? So we've got our wave processes, but now we've also got that weathering. So the weathering of wetting and drying. That wetting and drying actually decreases the structural integrity of the cliff. It weakens it. That's what that means. The wetting and drying weakens the cliff. It actually makes it more susceptible to more erosion. So when it's like that, the waves can erode it more easily, and so can wind. Anyways, I digress. So we have the wave pounding at fishermen in the notch. So that we've got the notch. We've got the waves pounding away here. What happens is that it gets undercut so much that the cliff face can no longer support itself, and it's going to collapse down into the ocean, which is going to actually create and help aid the continued creation of the shore platform. So when that sediment, the geology, the rocks, everything has fallen into the ocean from where the cliff faces collapsed, that just adds to that abrasion and to that wave process of attrition. All right, so we've got more and more attrition happening. So you will notice that there was this bit here that jutted out. So when all of this material here falls, it's going to fall to here. So we've got our tidal processes happening. So we've got these rocks, we've got the sediment all being contributing to attrition. It is going to eventually create a shore platform. So what happens here is that the energy is dissipated. So the waves come in, they've still got that strong energy, they're hitting here, as you can see, but it's not hitting the cliff anymore. So once the shore platform is created, cliff retreat doesn't happen as quickly anymore. All right. So the shore platform is basically an area of less erodible rock, so it's more resistant. And the erosional processes actually take a step back. So the wave pounding, wave attrition, the wave erosion processes actually are no longer the main process that affects our shore platforms. What becomes our main processes once the shore platform is created is actually our weathering processes. So our weathering of spray splash weathering. So that is the difference between the high tide and the low tide mark. Spray splash, this is a really great example here. We can see the wave has crashed in to Fisherman's Rock, and we can see where it is wet from the spray of the wave. So that there, the constant wetting and drying actually weakens the structure of the Fisherman's Rock. But not only that, once it does dry, it does leave its salt crystals behind, right? And we get the process of salt crystallization. So what happens here is once the water is evaporated by the sun, so we've got hydrological processes interacting with our climate processes. Once that water is eroded away, it leaves behind the salt. Salt embeds into the rocks, it expands the more drier it gets, weakening the rock, and as a result, we get a honeycomb pattern on the rock. So this is an example of the honeycomb pattern. So that is all over the Fisherman's Rock at Muriwai Beach. So the processes that we're seeing here is we've had the cliff face get a notch. The notch has gotten bigger and bigger and bigger. The cliff face has become so heavy it can't hold the material anymore. It drops down, and the wave processes of attrition really come into play. It forms the shore platform. The shore platform isn't going to stay there forever. Even though the wave erosion has slowed down, that weathering has definitely become more important in terms of erosion, just takes a lot longer. And eventually, the water layer weathering, so we've got our salt crystallization and our spray splash, will eventually lower the shore platform to under the sea level, and then once it's back there, then we've got our wave processes are going to come back in and be more of a force than the salt spray. But that is a thousand and thousands of years process right there. So basically, what you need to take from this one is that we've got climate makes the waves, makes the notch collapses on itself, the wave processes become less important, the weathering processes become more important, but at the end of the day, every feature on the headland on Otakameto Point is an erosional feature. So that is the key message to take away. We have all of those interacting natural processes that are eroding our headland at the Muriwai coastal environment.